So let's talk about the theory of evolution by natural selection. Note, the theory of evolution states that we have a changes in gene frequencies over time. It is not humans came from monkeys. That is not it. Basically, with evolution, we have a common ancestor, such as when we talked about 2 sections ago with our Clydes. We have this common ancestor in which everything descended from. And based on natural selection basically states that the strong will survive and reproduce. And so we have a trait from an organism that is allowing that specific organism to survive in that particular environment, and it's selected to be passed on to its offspring. And so I really like the story of the peppered moth. And so this picture here is kind of depicting the peppered moth. This picture right here is our first one that we're going to talk about. The light peppered moth blended in better with the trees before the Industrial Revolution. And so it didn't stand out as well, and so the birds ate the black peppered moth because it stood out and was able to be seen. The Industrial Revolution put a large amount of soot into our atmosphere, and because it put a large amount of soot into the atmosphere that landed on the trees, it actually made the trees bark darker. And that's where we have our second picture here. As the trees became darker, the lighter pepper moss started to stand out, and the dark peppered moss started to blend in. And so the one trait which was desirable pre-Industrial Revolution was no longer desirable post-Industrial Revolution. So we saw these birds starting to pick off the light-colored ones quicker than the dark-colored ones. So we see an increase in the dark peppered moss. Now, don't get me wrong. We still had light peppered moss. They just weren't the desirable trait anymore. It doesn't mean that trait completely disappeared. We just didn't see it as much. So over time, multiple generations, thousands of years, we would probably see a decrease or an overall elimination of the light peppered moth. But that's not the case right now. It's selected for the darker peppered moth, but we still have light peppered moths being produced. And so we haven't seen 2 separate species evolve yet from this. Note, in order for new species to form, they will no longer interbreed with the original species, or if they do, the offspring will not be viable. So an example of this, we have an East River finch and a West River finch. They are 2 different species of finch. They do, however, meet on the Missouri River, and they will sometimes breed with one another. The problem is they breed this little West-East River finch baby that ends up dying because it doesn't have depth perception. See, the East River and West River are 2 different types of finches with depth perception. One is a shallow diver and one is a deep diver because they dive for bugs. The problem is when they breed, the offspring don't have this equilibrium balance from one or the other, and they end up drowning or crashing into things. They don't have any depth perception, so they end up dying right away because of this. And so they don't have a viable offspring, which means that offspring is not reproducing on its own. And so that's an example. We have to have, so there's 2 different species of finches. They're producing an offspring, but it's not viable. The offspring it's not able to reproduce on its own, or it doesn't live. And so if you have a sterile offspring, you don't have a new species. Okay, but we did say that natural selection basically over time results in the inheritance of a population and changes in the survival of the fittest for the species. So if we look back at Lamarck's giraffes, where you had your changes in that species over time. Well, Darwin did say that we do have this. So with Lamarck, he just said, hey, short neck went to long neck in about 4 generations. We know that in the past we did have short neck giraffes. And there was a chance that the variation neck length from some of these giraffes became a little bit larger over time, and the larger giraffes kept breeding. And this was based on their food source. As the trees grew higher and higher, the giraffes needed to feed on the leaves. And so it was a struggle for the shorter neck giraffes to live because they didn't have a food source anymore. And so the longer neck giraffes kept breeding because it was a more desirable trait. And basically, over time, we started to see longer and longer neck giraffes from this. The giraffes with the longer necks had an advantage because they could reach the leaves where the shorter necked ones could not. So that long neck trait was more desirable than the short neck. And these giraffes were able to pass those traits on for the long neck over generations. Now, this didn't happen in like 100 years. This is a variation that took thousands. And so this is a change in the species. Now remember, if the trees did not change, we would not have seen the longer necked giraffes develop. But because the trees changed, the giraffes had to change too. And so the food source was a major factor in a lot of the species' fitness. Then we have descent with modification. Descent with modification, each species living has descended from some other species over time. And so we see here that we have our dinosaurs, which we know are a direct ancestor, distant ancestor, to modern day birds. And we have a little blue jay in the front. And so you can see here how we have a change in those species over time. And so this is a huge thing because it leads to adaptations. So here's Darwin's theory in a summary. Organisms differ and have a variation of in their heredity. Organisms produce more offspring will survive. Well, that makes sense that if you have more offspring produced, you're going to survive. If you don't have offspring that are producing or viable offspring, you will become extinct. Organisms compete for resources. The organism that is the most fit for that competition will survive. The other organism will not. Again, extinction. Organisms with advantage to survive to pass those advantages to their children. That would be kind of the basis of natural selection. And species alive today are descended with modification from a common ancestor. And so there is a species that we are related to in the distant past. Now, I want to talk about number 5 for a second. We know number 5 to be true because of DNA testing now. And so the modern advantages we have now become huge in proving or actually backing Darwin's theory of evolution. Now, one thing I do want to let you know is that we're going to talk about some of the evidence next time, and we're going to talk about the fossil record, geological disturbances, homologous body structure, and similarities in embryonic structure. So remember, there is evidence behind this, and we're not trying to change your point of view, but we're trying to give you something to look at for this. And so this is just basically looking at a scientific reasoning for why we have these similarities between species and why some species live and are able to reproduce over other species.